and next year or possibly even next semester, see how things roll, we might be able to get out into the factory there and see the process. But we've also got to fit in waterproofing today as well to cover that. So it's jumping essentially from claddings back into the bathroom and internal space in the house. So waterproofing is incredibly important. Yeah, I think I probably would have said it before when I was working in a lot of repair and reinstatement work. Like water damage is probably the most contributing factor to damage of buildings. Sort of waterproofing, then fire, then impact damage, or water damage, fire and impact damage. But certainly water damage is right up there. A lot of water damage happens from poor installation of roof plumbing, etc. But then there's a great deal of water damage happening in bathrooms from poor installation of plumbing or inadequate waterproofing under tiled areas. So I've got a sample here of a typical waterproofing membrane that goes. Will it fit out? Maybe I'll just pass it around in the container. Yeah, so that's a bit of waterproofing membrane which is dried. This is a membrane which is painted on, and we'll see that later on in the slides. Has anybody seen that when you've gone to a building that's under construction? Generally at lock-up, they're getting ready for doing the tile screed in the bathroom, and it's all painted green or blue or yeah, I think there's even like a pinkish purple one as well. That's the waterproofing membrane that stops water travelling from your tiles through into your concrete or your plasterboard or so. And it's also important for the understanding of waterproofing to understand there is a difference between waterproof and water resistant. So you've got some materials that are regarded as waterproof, so copper at a certain thickness and stainless steel are considered to be waterproof by the National Construction Code, and so are waterproof membranes. I think they comply to it's AS48 something or other. But there's an Australian standard for the production of waterproof membranes, so those materials are considered waterproof. However, things like concrete, like what we're standing on, yes, it will retain water, it will hold water, but it's not regarded as waterproof. It's regarded as water resistant. Same as your fibre cement sheet cladding. It's, so for your fibre cement sheet for walls, it's water resistant, not waterproof. And you've also got various different water resistant plasterboard products that can be used in wet areas, but they're not regarded as waterproof. And so it's important to understand that distinction between water resistant and waterproof.
So why have our wet areas got such a minimum standard? I remember, years ago we used to make stainless steel and copper trays that go into the shower.
Yeah.
Now we don't do it.
Yes, yeah, you don't do it now because there are preformed shower bases now. I'm not sure exactly. Well, there's several different types of materials actually that preformed shower bases are made from, but they're like a poly product, so it's it's a plastic type product, and there are these really high density type of plastics that shower bases are made out of now. I guess that's cheaper to manufacture, cheaper to transport, etc., than the steel products.
That waterproof, stuff like, you see on the block,
Yeah.
And they make a song and dance about the waterproofing that someone's put a hole in it and it's got to be redone 24 hours, yada yada yada.
Yeah.
That's obviously sealing, your sheeting,
Yeah.
If you just said cement, of course it's not.
Yeah.
So if you've got a slab and you waterproof that to stop that ingress, what about if, sorry, I'm diverging.
Yes.
If you had cement cement wall,
Mhm.
and you're then going to backfill on that, would you use, say, that waterproof paint on,
Mhm.
and then whack a sheet of the orange plastic in front of it? So the orange plastic might take most of the thing, but you've still got the waterproof membrane behind that to stop water ingressing into that cement wall.
And then what you're thinking about, or in this scenario, what you batten out and then you do some sort of sheeting or something like that.
No,
No?
I'm thinking the brickwork that I've got downstairs, that it's gonna, where the garage is, the bomb shelter, okay, that's gonna be all backfilled onto.
Oh right, yeah, okay,
Okay,
yeah,
so
yeah. So
as you know, as a protective barrier, water coming out of the hill. You know, rather than just putting a plastic sheet, like possibly paint it with that sheet as well.
No, that is very commonly done. Yeah, it's called tanking. So so it's applying a waterproof membrane to the outside of a wall that's going to have earth up against that, and that wall being internal wall. So that's what's called a positive side membrane. Yeah, tanking, and putting it on that side, on the outside of your wall, is called a positive side membrane. Painting it on the inside face of your wall is called a negative side membrane. Positive side membranes are far more reliable than your negative side membranes, typically because of the way that the water acts on various different things. You can get blistering on a negative side membrane, and then separation from your substrate, and then failure. Whereas, on the positive side, on the outside, it gets essentially, you don't get water forming underneath it. So that's very common. That's a great thing, because it's not only in bathrooms that waterproof membranes are used. Yes, they're not used very much in an external context, but certainly when you are burying portions of a building within the soil, then you should do a waterproof membrane on there. And I'm not sure on all the details around the protection of those membranes, but that one of the plastic sheeting to take a lot of the abrasion and knocks and things like that. Sounds like a reasonable sort of detail or good way to be thinking. Before commencing the job, check the project specifications and confirm that the products and processes specified are suitable and can practically be applied. So that's just what we're doing there with that membrane. Thinking about, okay, how are we going to make something waterproof, watertight. The products specified are compatible. That is highly important. And with a lot of these products that are based, based on chemicals that how do I say it, that enable them to be painted on and then dry and so enable them to be plastic and then hard. It's about the compatibility of those thinners and the chemicals within those compounds, which is super important. Some of you may have noticed, or have you ever done acrylic paint over top of oil-based paint, or these types of things. It's very important that all these products are compatible, and certainly with waterproofing, because it's a very high stakes game, because waterproofing has to work incredibly well, be very reliable. It is very important that the products are compatible. So where products are from different manufacturers, can they be used together, and where does the warranty lie? Actually, so this is not my presentation. This is one from Ardex. I would definitely be asking that question of the supplier if you are going to be using different products, because it is a legally a litigious area. So I've worked on a job analysing the thickness of a waterproofing membrane that had failed for submission to a determination of who was liable. Was it the applicator of the membrane? Was it the manufacturer of the membrane? So when you're talking about waterproofing, it is fairly high stakes, and these questions should be asked. All the materials, including products and tools required, are on site or available. So like any construction process, yes, you want to ensure that everything's on site, so you have a smooth job. What you don't want to be doing is being partway through a waterproof membrane installation and then not have the right stuff, and then mess up the job as a result because you've got half a membrane going off. So in application of waterproofing system, the waterproofing contractor must prevent the passage of water from one room to another, regardless of whether the contractor has adhered to every aspect of the standards and the right materials have been used in strict accordance with the manufacturer's product data sheet. If water leaks occur, the contractor is liable. So
how do you stop water going from one room to the other when there's only a stud wall and 2 bits of chip rock?
yeah, with a waterproofing membrane, and that's this. I guess that leads straight into the way that essentially the National Construction Code is constructed, and how it's applied specifically in relation to waterproofing. So the performance requirements, and can't reel it off the top of my head, the performance requirements, but basically performance requirements in relation to waterproofing say that if the waterproofing fails, then the standards of the NCC have not been met. So you've got your deemed to satisfy section relating to waterproofing within the National Construction Code, and it says this is how it should be done, etc., etc., etc. And as per AS 3740, but the performance requirement is that if it fails, then the NCC hasn't been met. So so it's incredibly important that waterproofing membranes are applied correctly. And if you have a job whereby water is making its way into a stud wall and making its way into other rooms, then then it's not
That's
fine.
exactly what happened with our house.
Right.
The laundry flooded and the bathroom got all the water going into it.
Mm.
Is that a case of, we had the same thing where the builder has instead of having a step down, say a laundry, there was no step down, so where you've got your water drain in the middle of the room, okay, that was 1 inch above the rest of the slab in the building. So when the water came back up in front of the house, so you'd say that's not a problem of any of that. That's just the problem of the idiot builder who didn't design a step down to retain a bit of water to start with.
Yeah.
So that's more the case if you're talking about like a step down in the shower, where you've got to waterproof that and you've got a wall coming into it.
No, right.
You'd have your step down there, you'd have your sheet coming over the step down, so water runs down and can't run back up. You'd waterproof that, then you'd have the sheet on, and then waterproof the whole block.
Ours is our blockage was caused by the orange plastic being stuck down it and concrete poured into it.
Oh, they didn't pull the orange.
Yeah.
Right. Yeah.
Something.
So so and that just a quick word as to the way that plumbing runs are typically done is that you'll have our bathroom here like this. We'll have our shower, our hand basin, and our toilet like that, and then our floor trap here. Your shower waste typically goes to your floor trap. Your hand basin waste typically goes to your floor trap. So you've got a I forget what they're called now. So you've got the trap and you've got various different bits coming into that there, and that's trap heading off. And this is our floor grate here. So you've got these various inlets coming in to your floor trap, and then that joins up with your 100mm pipe that comes out of your toilet here, and then it heads off. So that enables that if there are any blockages, etc., that water does come out that floor trap, or if you have excessive amounts of water in there, you've got a bit of room for expansion and so on, and water comes out of your floor trap momentarily and then disappears out afterwards. However, what that system relies upon is that you do have a reasonable set down for your bathroom. So that's why when we pour concrete slabs, we set down around 50 millimetres for our wet areas. So the height of the concrete in the wet area is about 50 millimetres lower than the rest of the slab. If we're doing it the same height, then when it comes to our floor trap overflowing, and we're dealing with decent volumes of water, well then you really have issues throughout the rest of the house. But yeah, keep moving on to the waterproofing. So waterproofing contractor accepts responsibilities from the time of work commencing. The principal ones are conditions of the substrate and the building. So the waterproofer has to check that the substrate is clean and in good order. So what they don't want is concrete that's had water and cement dry on top of it, and it's got all these flaky bits and flaking bits that will keep coming. So they'll have to scrape that back, and they'll have to make sure that it's all nice and clean. So when the waterproofing contractor commences work on a job, it is deemed that he's accepted all substrates as being suitable for membrane application. And that also includes things like any membranes that have been applied to the slab for curing and so on as well. Or deficient gaps between wall cladding and other, and issues around movement and expansion and contraction of certain things as well. When we talk about substrates for waterproofing, we're not only talking about floors, we also have to waterproof walls and sections of walls. Waterproofing contractors want to make sure that the carpentry is done correctly and we don't get any flexing in our frames as a result, because too much movement in that can cause a crack in a membrane. Typically that's going to crack at that corner junction where you've got a lot of exposure to moisture. So waterproof is going to want to ensure that even the substrates of the walls are correct. So should thoroughly inspect a job before commencing work. So all surfaces must be suitable to accept waterproofing membrane. So they must be smooth, porous and sound, or the contract should include cost to remedy such situations. In the application of a negative side hydrostatic membrane, so that's like internal basement walls, ensure that the substrate is sufficiently strong to withstand the hydrostatic pressure. So that means that you have a really good surface on your substrate, and that you can get sufficient bond with your membrane and the wall, because there is that pressure of water in behind that membrane, which can cause blistering, etc., and then failure of that membrane. So you need very good surfaces to work. Variations from standards or variations from good practice that are required should be approved by owner or prime contractor in writing before commencing work. So typically when you're dealing with a high stakes area, yes, it's advisable to get any sort of variation from standard practice in writing, so that liability can be handled off. Surface preparation for wet area waterproofing must be structurally sound. So cracking or movement of the substrate after a membrane has been installed is likely to cause the membrane to fracture. Clean and free from any contaminant materials. So membrane bond will fail at its weakest point. So if applied over dust, loose materials, or poorly bonded contaminants, will fail prematurely. Repair any holes and voids in the substrate. So when we've got concrete that's doing that, but then it has little bits in it like this, they need, or some, it depends on the shape of those bits. Certainly if we've got bits that sort of go back in a little bit like that, those type of things need to be rectified, because when you go painting your membrane on here, you won't get a really good bond in that section there. So waterproofers have to have a look for these sort of defects. Remove any protrusions and sharp edges. A uniform thickness membrane is very difficult to achieve over protrusions and sharp edges. So that's something you also have in concrete from time to time, or all sorts of substrates like rendered substrates. So where you've got, you know, a bit of a peak in something like that from a trowel that's been lifted, and you get those little sharp peaks. Waterproofing over that is a difficult thing to do, and you get, you know, and that's where it's going to fail. That little bit there, because it's hard to bond there. Very small surface area, can be easily snapped off. Concrete should be aged for 28 days, and screeds should be aged for 7 days. So typically with a concrete raft slab house, you're going to achieve that 28 days by the time you're at lock-up, anyhow, ready for doing your waterproofing and tiling. So generally for your standard sort of build, it's not an issue. However, aging a screed for 7 days may be an issue. There are several ways of waterproofing. There's you can waterproof straight onto a concrete slab and do a screed over top, and then have your tiling on top of the screed, and that enables a wet screed, which, you know, drains into this thing, which is a puddle flange. I'll pass that around for you to have a look at. That's essentially half of what a puddle flange is. So that goes into floor, and then you get your floor grate, which slots into it, and it's installed in the screed so that it enables water to bleed out of that cement screed into that puddle flange. So if any water gets underneath your tiles into your cement screed, it bleeds out and goes into that puddle flange, and then you have your waterproofing underneath all of that, stopping all of that from going into your concrete slab. That's one way of doing it. So you have your waterproof membrane underneath. Another way is to do waterproofing membrane on top of your cement screed, and then the other way is to do one underneath and one on top, a combination of the two. When you do a combination of the two, you still have to have a puddle flange that enables the bleeding of the water out. If you're doing an over and under like that, you've got waterproofing on top and bottom. Yes, that can be difficult to have. Well, it just takes timing and planning to be able to, or scheduling, to be able to have that screed to be 7 days old before waterproofing membrane is applied. So those sort of things have to be thought through. The scheduling has to be thought through when specifying these sort of details as well.
So I noticed on the last one, it's got, if you want to seal freshly laid concrete, to use that product.
Yeah.
Now, is that product as good as the first product, or is that an emergency thing?
Oh, what's that? So seal wet or freshly laid concrete with the WPM to allow to cure overnight provides a concrete curing membrane and barrier coat.
See, if it was really good, that's all you'd be using.
Oh, no. Oh, so this, what they're talking about here is this same company, Ardex, make a curing compound. So that curing compound is not a waterproofing membrane. What it is, so it spoke earlier on about having to ensure that products are compatible. So this is Gripset, another manufacturer of waterproofing membranes, but to Ardex. But because Ardex make these other things, because they're the one company, they will want to ensure that their products are actually compatible. And so if you've got a curing compound put on your concrete slab to help that cure, or they recommend that because they recommend it because their product, right, first and foremost, but they recommend that because it's compatible then with their waterproofing membrane. So they say, use that one, then you can use our waterproofing membrane rather than use someone else's. We don't know what's going to happen if you put our membrane on top. So the curing compound, that's different from a waterproofing membrane in that a curing compound helps stop moisture coming out of a slab, because when you pour a slab, what you want is that slab to go off and to harden really slowly. You want to slow down that moisture loss as much as possible, because then you get a stronger concrete. Because if you give it time, all the lattice forms in the concrete, and the longer you give it, the better lattice forms, and so that's why a curing compound is used.
So
And
that's different to putting a sealant on it, which is a moisture barrier inside the concrete.
That is different once again.
Once again, okay.
Yeah.
And where it says, just going back one,
Yeah.
it says ensure the substrate is dry, 7% moisture or less. So if you've had a slab sitting around for a full winter, and obviously it's exposed to rain, and whether it's had that much water sitting in that area of the bathroom for a whole winter.
Yeah.
You virtually got to wait until that. You'd have to test the test the cement to see that, okay, I'm now at 7%. I'm good to go.
Yes, exactly. Yeah. So you've got people who have moisture readers. So the engineering firm I used to work with, most of the people there in their kit had a moisture
So you
reader.
wouldn't just rely on the fact that, okay, we're now summer, it's dried out because we've had 30-degree temperatures.
How did the little Italians do it in the old days?
I don't. But there's moisture readers now. It's a very simple piece of equipment, because all it does is send an electrical current from one position to another position, and it measures how much current has passed through there, and it goes, there must be that much water in there. Find someone who's got one of those, or possibly if you've got somebody installing your waterproofing membrane, it's up to them to test that and go, oh yes, okay, there's not much moisture in this concrete, we can do it, or we can't. So types of under tile membranes. Waterproofing wet areas, but also don't forget balconies. Balconies have issues, and it's always important that with a balcony, and this is more of an installation thing than a design thing, that it slopes slightly towards, or slopes slightly away from the house. Yeah, it seems like a simple thing, but that has to be gotten right, and that's not always gotten right, that slope away from the house. But balconies should also be waterproof. What we don't want to see happening is, even with concrete balconies, the water that leaches its way through and then drips on the neighbours underneath and creates sort of white salty deposits on the underneath of the concrete balcony. It's not much fun for anyone. So balconies need to be waterproof. So in the formation of a vapor barrier designed to prevent water entering or escaping from various sections or rooms of a building or structure, so internally. Once again, water damage is one of the biggest problems faced by the building industry, causing decay and deterioration. And sometimes it's not only limited to that area that's involved. I think I've told you about a place we had to work on down in McCracken. It wasn't a waterproofing issue, but it was an issue with the way the balcony was done, etc. Destroyed framing for the balcony and the flooring for the balcony, but also destroyed the framing. Well, that balcony shared the floor joists with the inside of the house for a suspended floor. Destroyed those floor joists. Replacing that is a massive job from a very simple detail which was gotten wrong on the balcony. Ripping up stuff internally. Ripping up suspended floors internally is a massive job.
So has this got anything to do with, when you look at the extreme level of it, where the actual reinforcing starts to rust and come out? Is that from a wet issue or just bad workmanship? Or?
When you get that expanding of reinforcing mesh, which is called concrete cancer. That's caused by several things. One of the really common things is where you don't have adequate concrete coverage. So if we've got a bit of concrete, there's a piece of concrete here like this, and let's say that's a piece that sticks out from a building. It's a balcony or something like that. We have to ensure that there is adequate coverage to that reinforcing in there. because concrete does wick moisture. Now, not all sections of concrete are required to be waterproof. Like if these concrete cast stairs that we've got around Tonsley, if they were outside, they don't have to be waterproofed. But what they do have to get, what does have to be designed in, and what does have to be done correctly on site is that there is adequate concrete coverage to that steel. That's typically what goes wrong. Is you've got steel just put in and it's like 20 millimeters away from the formwork or so. You get some concrete, let's say it's 20 millimeters, but you've got 20 mil aggregates as well. You get gaps and whatever happening around that, moisture gets in there.
Yeah, so you don't
rust
blame
expands.
The contractor that put the wet membranes in and all that sort of thing. It's a totally different issue.
Well, what I'm saying is it's from a variety of issues. That's probably the most common, but certainly if you've got things like, and I've seen it before, where you've got like a tennis court on top of I saw a tennis court on top of a car garage with a that might have had a Bondex slab, that one, but let's say it's a slab that has reinforcing in it, and so that had, because it was a tennis court with grass, that had a waterproof membrane underneath it. Yes, if that waterproof membrane is not done really well, you'll get water leaching into that concrete, rusting the steel. It expands, it cracks, and causes more issues. So waterproofing in some instances is an issue for external concrete, but typically, the main one is that you see around the place is just where steel hasn't had adequate coverage to it. And beyond that, then you have it happening in some marine environments, and it's almost impossible to avoid in some marine environments. And possibly the issue is with the idea in the first place, or the specifications.
Is that like the other week I was down at Marina, and all Marina is concrete box section pontoons.
Right. Yeah.
I noticed one of them, and it didn't look like anybody had hit it, but obviously water's got inside it because it's had a bit of a tilt. Would it be that sort of like over time something's gone and it's allowed to have a bit of concrete cancer and it's broken off or something?
Maybe, yeah. Don't
I
know.
don't know.
But
I looked at it and I thought concrete pontoons and salt water. It's sort of, you sort of half think it's a recipe for disaster.
well, yeah. Steel and salt water is can be a recipe. But look, you've got plenty of bridges, etc., with cast concrete piles that live a very long time in highly corrosive marine environments. So
almost every marina has floating concrete pontoons.
right. Yeah.
I thought it was crazy. The first time I made molds for them, and the guys just say they fill them up with styrofoam, then pour the concrete over the top of it. And I thought, who calculated whether they were going to float?
Yeah, it would, because I mean, like my boat, it's got like that much styrene under the floor, and inside side panels, and I've actually the what do you call it, the boat manufacturer did a thing that you can't sink the boat. It just like they actually put it and flooded it, and had 5 blokes standing in it. There's enough styrene in the actual construction that it won't.
See, I just can't see. Salt water will get into concrete, and must do damage to the concrete if it's floating. But like I said, the bridge pylons are being sitting in salt water.
Yeah, and it's just about doing it correctly. So it's about those details and about engineers working out, how hydrophilic their concrete is, where the water's going to get to that steel, all that sort of stuff. But that's that sort of high end stuff. So for your waterproof membranes within buildings, you've got the Australian Standard 3740 that sets out how they should be applied, where they should be applied, etc. It is important to understand those details in there, and it's important to understand how those details differ for different situations. Whether it is a preformed shower base, so a shower base that that does all the waterproofing for you, whether it's a shower base, preformed shower base with a hob. So a hob is a section that goes up higher than the floor. Whether it's a hobless bath shower, whether it's a shower that the floor gradient just slopes back to the floor trap in the shower. These are all important aspects that how to say it. It means the details in relation to waterproofing have to be done differently. And also another really interesting one is, actually I'll get in, I won't digress too much, I'll get into it a little bit later, but where you're doing bathrooms for disabled access, that throws some interesting things into the mix. So we've got an Australian standard for manufacture and detailing of shower screens, Australian standard for acceptability and compatibility of direct fixing under tile membranes, and Australian standard for construction detailing and waterproofing of external balconies and decks. So it governs the required application of the waterproof membrane, including minimum surfaces within internal wet areas. So that's what I was talking about, your waterproofing details, where it should be waterproof, etc. Yeah, and this is what I referred to earlier. Note there is an overriding clause in BCA that the waterproof membrane shall prevent water transferring from one room to another, regardless of whether or not the waterproofing was done in accordance with the standard. So, yeah, it's important to be careful and conservative with waterproof membranes. Details of areas required to be waterproof and water resistant under this standard will be covered in a subsequent module. You also have different classes of membranes and different flexibility of membranes. And so these details, set out in AS 4858, but there are also some of these details within the National Construction Code as well. But typically, so you've got your various different classes of membranes. You've got your flexibility of membranes. Now this one I think is a class 3 membrane. It's not. Oh, here we go. I've got a bit pops out here. Doesn't seem all that flexible, but that's still that's got a decent amount of flex in it. That you get a building doing buildings moving millimeters or so. That has a reasonable amount of flexibility in it, and is not going to fail that easily at joints. That means that you can get away with a really simple detail here, which is a cove of silicon. So silicon, which is applied in a cove fashion. Now, I guess waterproofers and tilers and so on will bang on about how silicon should be applied and so on. It's all very, very interesting. But there are various different tools for getting that right and getting a really nice cove and things like that on your silicon. So that's by and large the most common detail, where it's just a bead of silicon that's been troweled off into a cove right in the corner. For other less flexible membranes, you've got silicon and then a tape on the outside, and then for your low flexibility membranes, you've got a bead breaker and then the masking tape and then the membrane on top. But yeah, typically if you go out to buy a waterproofing membrane, you're going to buy a class 3 membrane, one that has a lot of flexibility anyhow. So that's by and large the most common detail that will be worked with. I think we've been over that fairly well. So membrane should be placed under or over the tile bed screed. So does everybody in this room know what a tile bed screed is? Does anybody doesn't know what a tile bed screed is? No? All right, I'll draw one up to the best I can. So we've poured our concrete slab, and that's our edge beam there. This is our concrete slab that we're going to be building our house on. There we go, rebaked brick veneer. Now, what we'll do for the bathroom is when we're pouring that concrete slab, we'll set in some pieces of timber at 50mm high. and cast that bathroom flooring lower. Now, I say 50 millimetres high, but that differs. So, can anybody think why it would be different in some scenarios than another? Why that height would differ? Yeah, the water, yeah. Yeah. Yeah, I think I know what you. I'll just yeah. So you've got to get the water to your drain, and you've got to have a certain slope on your floor to achieve that. Now, if I'm building a wet area the size of this room here, and I've got my floor trap right over in the corner there, I'm going to have about 8 or 9 metres of slope before it hits that floor trap. Because floors in a wet area have to be between 1 in 80 fall and 1 in 100 fall, that means from by the time I get to that trap over there, that bit over there is going to be about 100 millimetres thick. Well, I've got about 100 millimetres of fall from one side to the other. So that's why this will differ. If we've got a really large bathroom, then this set down has to be larger. If we're talking about a very small wet area, that set down can be much smaller. One of the things though with the installation of a puddle flange, so this is our puddle flange in here, we have to have about 25 millimetres or 20 millimetres of screed at that puddle flange where that is terminating, and then our floor grate goes in there, our screed comes over it. We still need that thickness of screed for that to work. If we've only got 5 millimetres here, then it doesn't drain out properly. So we lose 20 mil here already anyhow. And then our screed is going to start thick here till it gets thinner there, like that. So we start off with a flat floor in our bathroom, and then we put all this sand, cement, water screed in there, and have that troweled to have the fall, so we don't get puddling and pooling anywhere, that everything goes to this floor trap here. So it's much like concrete, except it doesn't have the coarse aggregate in it. And then that is troweled off, and then our tiles go on top of that. So, and that waterproofing membrane, so when we've cast our concrete, after we've done that, we take that piece of timber away and our screed goes there. We never leave the piece of concrete in the sun.
This is done in the whole bathroom, not just the shower part. I assume it's the whole.
That's done in the whole bathroom. And sometimes what you have is you have a set down for your shower within a bathroom which is also set down. So you have like a 50 mil set down for your bathroom and another 20, 30 mil set down for your shower. Because within a shower you need between 1 in 60 and 1 in 80 fall for the floor in a shower. For the fall in your bathroom or your wet area, it has to be between 1 in 80 and 1 in 100. In terms of that, also beware that in the NCC, if you go to that right now and you go go into sanitary, I forget what the section's called, but the sanitary facilities, for wet areas and bathrooms, it'll say a fall of 1:100 for the floor, and a fall of 1:100, 1:80 for the bathroom, for the shower. But as with every state, there's these appendices at the end of the NCC, and Australia has an appendix, and it specifically relates to bathrooms and falls in floors. So be aware of that when you read the NCC. There's a specific appendix for South Australia, and there are some details in there that we in South Australia have to abide by, the other states don't, and that relates to falls in wet areas. So that's the tile bed screed. So it's a cementitious screed that goes down, and you can get the slope onto it. This is for these are two different ways. So underbed screed. How to say it? So membranes may be placed over or under the tile bed screed. If the membrane is placed underneath it, then the screed always remains saturated, breeding mold, fungi, odours, and so on. Bed screed must bond firmly to membrane, etc. If it's over top of that, over top of the screed remains dry, and if that waterproofing membrane isn't breached, then all of that water goes into your puddle flange and doesn't keep your screed wet. Okay, I noticed that we've gone a little bit over time, so I'll just go really quickly into the areas that do need to be waterproofed and explain just some very important bits of it. By all means, work your way through these.
Sorry, actually, I want to ask a question about the pipe on the flange. How angle have to be principally?
I don't know. Yeah, and that is definitely a question for a plumber, and it's also a very specific question as well, because in the plumbing code it refers to different slopes of pipes for different diameters and flow rates, etc. So
Because now I'm looking at for piping, they call the push fit. You can push it and waterproof and could keep a bit of detergent. Actually, you don't find any house detergent. You fit in the pipe with the flange.
yeah,
And after 2 minutes, will be blocked, you don't need, they call it push fit.
right, but
And it's waterproof. Downstairs is a waterproof, but upstairs and level of the flange, you have to waterproof with the ceramic and the material you shop.
yeah, so you can get push fit now for drainage pipes as well, because I've always known push fit for supply pipes, but you can get it for drainage as well.
And inside,
cool.
it's they call the nanotechnology.
Yeah.
Anything doesn't stuck inside the pipe because sometimes the hair, everything, the soap or everything, where it is stuck in the pipe.
Yeah, and repels.
No, anything doesn't stuck in the pipe.
Yeah, right. Yeah, and what company are producing that?
Actually, I wanted the company to supply the push fit.
Which company?
Geberit.
Yeah,
Geberit. Geberit.
Mm. Yeah. Cool. Oh, thank you. Yeah. So various different details in here, and where it is very important to adhere to the details and look at the details and see what conforms. What defines an enclosed shower, because when you're dealing with an enclosed shower and an unenclosed shower, the details around waterproofing differ. To put it in a nutshell, if we're doing an enclosed shower, you have to waterproof the entire floor within the enclosed shower. If we're doing an unenclosed shower, you have to do the waterproofing to a radius of 1500 millimeters from the shower rose. So the shower rose is the bit where the water comes out. If your shower rose is on a hose, what does that do?
The length of the hose is the length of the ridge plus the width.
Yeah, exactly. So it might as well be a whole floor. If you got and the thing is, you don't know if you install a shower rose, like one that's fixed onto a wall, whether somebody at a later time is going to go, oh yeah, I want the one with the hose. Put one with the hose on there. So yeah. So you might as well do the whole floor is that. And that's the thing about disabled bathrooms, is with disabled bathrooms you can't have hobs, you can't have set downs. The greatest difference in floor surface area you can have is 3 millimeters with a sharp arrow, so 5 millimeters with a beveled edge. So with disabled access bathrooms, basically you have to waterproof the whole floor.
So
as well.
that's what they call it, with all that sort of stuff. Is that what they termed as a wet room?
Oh, I don't know.
Like they have these bathrooms where there's no screen in the shower. It's just.
Yeah, well so that's an unenclosed shower. Yeah. And I'll just quickly flick down. So within these slides, and these slides are taken, well, these details have been reinterpreted from AS 3740, but there are all these details in here as to where you have to waterproof. So within the shower, up to 1800 millimeters high on the wall, and then for extents outside of the shower area, so this one's 25 millimeters there, or 75 millimeters outside the shower. And one very typical one is turn the waterproofing up 150 millimeters up the inside face of the wall for any junction as well. But all of these details will differ for the type of shower and the situation that you're in. So we won't pour through those today. But
so like that, what you've got there,
yep.
say for instance, let's just say you've got tiling in that blue area where you've got your water.
Yeah.
Okay. And tiling finishes like the blue line there.
Mm-hmm.
The plasterboard where the pink is.
Yep.
On the other side.
Yep.
Glass,
Yes.
is not covered by any water. Who's liable when it fails? Because water's going to get on that. And stuff it.
Yeah. So there within AS 3740, there are also recommendations, and within the National Construction Code, of what substrates need to be water resistant and for what distance from what facilities they need to be water resistant as well. So
that would have been a water resistant board as opposed to just plasterboard next to your bar.
Yeah, yeah, and as an installer or a designer, I think it's always best, because you're not talking about a huge difference in cost between these products. You might as well specify water-resistant plasterboard to the whole room. So that, because you can use water-resistant plasterboard and then have a waterproof membrane on it for where it needs to be waterproofed, and then the rest is water-resistant. But I think that's cheapskate to the max. If you're going water-resistant only to that edge of where the NCC says you need to, and then just standard plasterboard for the rest, you might as well go water resistant or moisture resistant plasterboard, or fibre cement sheet linings. And the same thing goes for your flooring as well. Yes, you can use plywood and chipboard like Structurafloor in certain situations as flooring substrates for bathrooms. I tend to think it's not a good idea. The NCC allows it, the codes allow it in certain situations, but you've always got to remember that NCC sets the base minimum standards, and sometimes it's not. Sometimes it's a better idea to just go that little bit extra extent and have your thick sheet flooring all throughout your wet areas. So I'll leave it at that for today. So thank you very much for coming along. I'll put this video up as well